In this video, we're going to talk about the Math 4 practice quiz number 3 on regression. Number 1 says, anthropologists use a linear model that relates femur length to height. The model allows an anthropologist to determine the height of an individual when only a partial skeleton, including the femur, is found. In this problem, we find the model by analyzing the data on femur length and height for the 10 males given in the table. It says to make a scatter plot of the data in Desmos, and then using that scatter plot, describe the association you see between the two variables. Make sure to mention the form, direction, and strength. Okay, so I'm going to start by adding a table in Desmos and type in my data. So in this part of the process, you just want to be extra careful that you don't miss any numbers, because that could change your answers, of course. So 45.2, I see I got 44.7, 44.5, 42.7, 39.5, and 38.0. Okay. So for my y values, I've got 178.5, 173.6, 164.8, 163.7, 168.3, 165, 155.4, and last but not least, we got 155. Okay, so I've typed in all of my data, and I can change the window if I want to fit this data. So remember, you can easily change your window if you want and make the x-axis look more like your range of values. So femur length, it looks like my smallest value was 38. So I'm just going to put like 30 as my smallest. And then the highest femur length was 50, so I'm going to put like 55. I can be a little outside my range. For the height, which is my y value, so that was like my x1 and y1. So for the height, I'm going to put, the smallest looks like it was 155. So let's put 140, something a little smaller than that. And the largest was 178.5, so I'm going to put 180, something a little bigger, just to make sure I have a nice picture of my scatter plot. So I can tell that this is a linear regression. It looks like a line would go through it, and they've said linear model, and they just want us to describe the strength, direction, and form. So linear, and it looks like it is a positive. Let me put this in a better order. It looks like a positive. It's kind of weak. It's not very close together. So I would call this a weak, positive, linear plot. Or we could say correlation. Or let's just leave it at that. Weak, positive, and linear. Those are the words I would be looking for on your quiz. Number 2 says, using the data set from number 1, find a linear regression equation that models the data. So I want to type in my, underneath that table, you want to add another line and type in your equation for your prediction equation. Remember, you need y with a subscript of 1, and then you need that approximate symbol. Let's see, make sure it's not in the subscript. Then mx with a subscript of 1 again, and then plus b. Okay, so I see I have a linear model. Now it does look like r squared is 0.93. So that is pretty strong. I'm going to change my answer to a strong positive linear model. And that line going through my points makes it look even a little stronger now over there. And now I'm going to write my equation out. So looking at Desmos, I can pick out the m and the b and round them off to write the equation. So y equals 1.9x, that's like my slope, plus the b value, which was 80.7. So I just rounded those off. Notice you don't need any subscripts anymore when you write the equation. Now it says for number 3, an anthropologist finds a femur of length 58 centimeters. Use your prediction equation from number 1 to find out how tall the person was and show your work and write your answer below. So really this needs to be number 2. I'll fix that for future reference. But we need to plug it in. So showing your work means show the equation and where you plugged in your value. And this is femur length, which is our x. So put the 58 for the x, and then plus the b, which we know is 80.7. And then just type all that in the calculator. You don't need y equals, just the numbers. So 1.9 times 58 plus 80.7 gives me 190.9 centimeters would be the height. So like that gives me the height when I plug in the femur for the x. Okay, number 4 says a cup of soup is left on a countertop to cool. The table below gives the temperatures in degrees Fahrenheit of the soup recorded over a 10-minute period. Find the best fit model. We're looking for, is it linear, quadratic, or exponential for the data? Write your equation and explain what makes that one the best fit. Okay, so first things first, let's clear out Desmos to type in our new data because we're done with this set. I'm going to hit the home button to put it back to normal. I'm going to add a new table and I'm going to put the values in there. So 0, 2, 4, 6, 8, and 10. And then 180.2, 165.8, 146.3, 135.4, 127.7, and 110.5. All right, so we've typed it in and notice we don't see anything yet. So let's change our range of X, our domain and our range in the little wrench. So notice I'm hitting that little wrench in the top corner. I'm gonna make X go from 0 to 10 because that's what it was in my table. And I'm gonna make Y go from 100 to 200 because that would be plenty for my data. And I can look and see what it kind of looks like now. Okay, but we want to know really truly what is the best fit. So let's type all of our prediction equations in here and just see what those R square values are, because that's really the best way we could tell. It looks like it would be linear, but we're not sure. So let's just type it in and be sure. So we can put y sub 1 is approximately mx sub 1. It's a little tedious typing this on the iPad, but I get there. Plus b. So I see linear. I'm just going to jot down over here for my reference, and it's a good place to show my work over here. That linear R squared was 0.9856. Okay, so I'm going to compare that in a minute to exponential. So let's start typing. Exponential would be y sub 1 is approximately ab to the x sub 1. So let's write that down. Exponential, I'm going to use a different color. Exponential R squared equals 0.9899. All right, and then quadratic, let's put that one in green and find what that R squared would be, just to make sure we got the best model, because that's really the mathematical way to find the best one. So I need y subscript 1 again is approximately a, and then we need x to have a subscript of 1 and square it. Then plus bx subscript 1, and then plus c. Okay, so that R squared is 0.9897. So if you compare the 3 R square values, the exponential one is the one that is closest to 1. So that's going to be the winner. And so let's go back to our exponential equation in Desmos. We haven't erased it, which is good, so we can write it out. And write y equals the a, which we're looking over here. A is 180.3 times b, which is 0.95, and then just put your x in the exponent. And why is this one the best fit? So we can write the r squared value is closest to 1. So that is definitely the definitive way to tell, because the linear one looks like it's a pretty good fit just by looking at the graph. Exponential looks like a good fit, and quadratic really isn't a bad fit. Like, they're all actually really good. So the way to tell this one is best is to look at the r squared value. And you could mention those other ways, but that's the strongest piece of evidence we have. So I'm just going to leave that for my answer. Number 5 says a study compared the speed X in miles per hour and the average fuel economy Y in miles per gallon for cars. The results are shown in the table. Find a quadratic model in standard form for the data. Using Desmos, find a best fit model for the data. Write out the equation and explain what makes this the best fit for this data. So for your practice quiz, on your quiz, it's going to not say quadratic right there. I didn't mean to leave that word in there. So beware that, like, this one won't say quadratic or exponential or linear. You've got to figure out like which one would be best again, just like that last question. So start by adding your table again. So let's just go through the same steps we did last time and pretend like it doesn't say that. So 30, 35, 40... Desmos usually catches on to what you're doing with these numbers, and it's helpful. So I'm just hitting enter to save some time. And then type 22.3, 25.5, 27.5, 29, 28.8, 30, 29.9, 30.2, 30.4, 28.8, 27.4, and 25.3. So I got all my data typed in. Let's put home up there to make it look normal again. And then we can change our data range in the wrench to make it match more of our numbers here. So I'm going to put the lowest X is 10 and the highest is 80. I always like to put a number a little smaller than the smallest and a little larger than the largest, just to be on the safe side, so I'm not looking at one of my points on the edge of my screen. And then for the Y values, it looks like 20 would be a good low number. And let's say 35 looks like a good high value for that. So I can kind of tell that it looks quadratic for sure. But if we just type in all of our options again to make sure, let's say we'll start with quadratic. So Y subscript 1, I need to scooch over, is approximately AX subscript 1 plus BX subscript 1 plus C. Okay, so quadratic, let's just write a note, is R squared is 0.1288. That looks really low. Did I miss a number anywhere? Anything look strange? I think I'm missing a square. That's what it is. I can tell that just looks off. So let's go back over here to this X. Let's see if it'll help to add. There we go. I added this square. I was missing the square on my first term in my equation. So now that makes more sense. So R squared would equal 0.9646 for the quadratic. Now leave that there, and in the next row do linear. So Y subscript 1 is approximately MX subscript 1 plus B. Okay, we can definitely tell that doesn't look good. So linear R squared was 0.1288. That kind of looked like the last one we saw because I didn't have it squared. And then exponential, let's just check that one out for good measure, because like I say, on the one on your quiz, it won't say the word quadratic. You have to figure out which one is the best fit. So you got to be able to type all of them in and compare those R square values. So let's do one more. Y subscript 1 is approximately A, B, to the x and then add a subscript 1. And we see that it's 0.1206. So then quadratic is clearly the best fit for this one. So you go back up to your equation and let's write y equals, and plug in the a, b, and c. Don't leave those as letters. So let's put negative 0.008x squared plus b is 0.75x plus c, which is 13.5. And why is this the best fit? It's because the r square value for quadratic was the closest to 1. Also, the data fits best around the quadratic model. Like your points are definitely closer to the quadratic model on the graph. See, if we take away the linear, turn that one off, and the exponential, you can see that that definitely passed through most of your points on your scatter plot. Okay, so that is it for practice quiz number